Hi everyone, this is going to be the last video of this unit, and this is kind of the big picture on why we are working with imaginary numbers, in the sense that we need to be able to solve quadratics now that normally we'd have gotten no real solutions. So I hope you enjoy my little joke off to the side, and you will see that we are going to start getting imaginary numbers for our answers. So let's take a look at number one. So there's no linear term here, so I want to get the x squared by itself, so I'm going to add 40 to both sides. So I get 2x squared to equal 40. Divide by 2 because the square term is still not isolated, and we get x squared to equal 20. Now there's nothing unusual about this. There's no negative number, so just like we have in the past, I'm going to take the square root of both sides and make sure that I simplify my radical. So 24 and 5, 2 and 2. So x equals, remember, two equations plus or minus 2 root 5. So remember that whatever you can take a group of goes on the outside. Whatever is left over, you box it and take it home. Okay. All right, so let's take a look at number 2. So same thing, we're going to add 27 to both sides. So negative 3x squared equals 27. Divide by negative 3, and we get x squared to equal negative 9. Now in the past, when we went to go take the square root, we would say no solutions. Now that we know what imaginary numbers solutions are, we can solve this. So remember to take care of the I first. So I'm going to take the I out and then simplify my radical. So the square root of 9 is 3. So I get plus or minus 3i. And ironically, that's what's exactly in the comic. Okay. So once again, took the square root, take care of the I first, so take it out, and you're left with root 9. Simplify the radical, that's a perfect square. And remember that the I goes behind an integer. Okay, let's take a look at number 3. So this time we have a squared operation of addition. So I need to isolate that entire term, or expression, sorry. So y plus 3 squared equals 2. Now that it's isolated, I go ahead and take the square root. Nothing different about this problem than we've done in the past. Okay. Now the one thing, remember that when you are solving, the whole point is to get the variable by itself. So if I were to leave my answer like this would not be correct because the variable is not by itself. So I'm going to go ahead and subtract 3. So negative 3 plus or minus root 2. Remember, you cannot combine those. Those are not like terms. Okay. Alrighty, let's take a look at number 4. Okay. So once again, we have a squared quantity here. So this is what I need to isolate. I work from the outside in. So I'm going to subtract 18. Okay. The squared expression is still not isolated, so I'm going to multiply both sides by 2. And I get w plus 4 squared equals negative 24. Okay. So I go ahead and take the square root of both sides, and I can do this now. So do some work off to the side, or just know that you need to take the I out. So plus or minus, maybe write that a little bit, plus or minus I root 24. Okay, but you are not done because 24 can be simplified. So 24 breaks down into 6 and 4. Okay, so I can take a 2 out and I'm left with a 6 underneath. So I now have w plus 4 equals plus or minus 2i root 6. Okay, again, the variable is not isolated. I still need to do that last step. What's the inverse of addition and subtraction? So w equals -4 plus or minus 2I root 6. So the first 4 examples, what I did, I used square roots for all of them because either there wasn't a linear term or there was a squared expression. Okay. All right, let's jump down to number 6. Okay. For number 6, we cannot use square roots because there is a linear term, so we're going to have to use the good old quadratic formula. So the quadratic formula is opposite b plus or minus b squared minus 4ac all over 2a. Okay. So we're just going to do one example on this page and then go to the final page. So x equals opposite b plus or minus b squared minus 4ac all over 2a. So that gives me 4 plus or minus 16 minus 28. Make sure that you are careful of negatives. So I have 4 plus or minus root -12 over -14. Remember to not cancel terms across plus or minus signs, and we can't divide underneath a radical. So instead, we're going to take care of the I first. And also notice that this breaks down into 4 and 3, 2 and 2. So I have now x equals 4 plus or minus 2I root 3 over -14. So I could take a group of 2's out, so that's what came out. I boxed my leftovers, and I made sure I took my I out. Okay, remember that it is imperative that when you take out a square root of a -1, that it becomes an I, and you don't just throw a random negative out. Okay, then see if you can complete the heart, or you can split it like we talked about in previous videos, which you can. This is going to be -2 over 7 plus or minus I root 3 over 7. So some of you might wonder why, like, where did this negative go? Well, when you do this side of half of the heart, that becomes -2 sevenths. And this side of the heart, when you divide a negative by a negative, it's a positive. You divide by a positive, you get a negative. So it's still plus or minus. It doesn't change that. All right, let's go to the last page of the notes for this unit. Okay. So the directions say find the zeros of the given function. So if it says find the zeros, then that means you have to find real and or imaginary. Okay. If it says just find the reals, then you would have nothing with regards to imaginary numbers. But if it says find the zeros, that encompasses all types. Okay. So this is in factored form for us already. So anything that contains a variable must be set equal to 0. So we have a factor here, and we have a factor here. So x minus 2 equals 0, and then x squared plus 2x plus 1 equals 0. So this one's actually pretty straightforward. So x equals 2, and then you have a quadratic with the other equation. Always look to see if you can use square roots, which you can't, and then factor. And this one actually factors pretty fast. So x plus 1 times x plus 1, or you could have written it as x plus 1 squared equals 0. It's the same thing. And then since this is going to repeat itself, you just do 1. So x equals -1 and 2. Okay, so very similar to something we've done already before. It's just now that it's already factored for you, and with the possibility that you could get imaginary numbers. So I'm sure you can predict the future here and realize that that's probably going to happen in the next example. All right, so again, anything with a variable must be set equal to 0. Okay, the one on the left, pretty straightforward, right? To solve for x, it's a linear equation. Okay, on the right, so we can't use square roots. We could try to factor this. So multiply a times c, that's 9, that's -3. Are there two numbers that multiply to 9 and add to -3? No such luck. So we have to use our good old friend, the quadratic formula. So x equals opposite b plus or minus b squared minus 4 times a times c all over 2a. So this gives me 3 plus or minus 9 minus 36 over 18. Okay, I know I stressed this so much when I originally taught this to you guys, and I'm going to continue to stress it. Write out your steps so that you don't make little arithmetic errors. So, write this out, double check the negatives. And then 9 minus 36, like if you say that out loud, logically, that means you should get a negative number underneath because you are subtracting a bigger number from a smaller number. Okay, and then, we look underneath the radical, notice that we do have a negative underneath, but we can solve that now. So 3 plus or minus I root 27 over 18. Again, don't cancel these. This is a no-go. It's illegal in math. Instead, we got to see if we can simplify 27, which we can. This is 9 and 3, 3 and 3. So I have 3 plus or minus 3i root 3 all over 18. Okay, so I could take a 3 out, and I was actually left with a 3 underneath. And then I can simplify this to 1/6 plus or minus I root 3 over 6. So you can split the fraction, right? So 3 over 18 plus or minus 3i root 3 over 18. Remember to leave the radical alone once you simplify it. You can't divide unless this was a radical, which it isn't. We can't do that. That's not, root 3 and 3 are not the same thing. Okay? Okie doke. Let's take a look at number 3. Same thing. Set anything with a variable equal to 0. Okay. The nice thing about this example is that we can actually use square roots for both. Okay, make sure you isolate the squared term, so I still need to divide by 4. Take the square root, so x equals plus or minus 3 over 2. And then for the other equation, that's x squared equals -8. Take the square root, x equals plus or minus 2i root 2. So 8 breaks into 4 and 2, 2 and 2, and then we had to take the I out. Okay. All right, 2 more examples and then we are done. So once again, read these problems and read them out loud to yourself too if you need to. So given f of x equals 3x squared plus 5x minus y, or minus 1, and f of x equals 3, solve for x. So I am missing x. And remember that f of x is a fancy way to just represent y. So we're going to take this 3 and we're going to plug it in. So 3 equals 3x squared plus 5x minus 1. And then to use the quadratic formula or to factor, it has to be set equal to 0. So 0 equals 3x squared plus 5x minus 4. Okay, and then this would be another example where you guys would have to use the quadratic formula, but we've done enough of those. So let's go ahead and go to the last example. So this says evaluate, which means we're substituting something in for x. So we have f of 3 minus 2i equals 3 minus 2i squared minus 2 times 3 minus 2i plus 5. Remember to expand this, right? Don't be the one that does something illegal in math class. So we have 3 minus 2i times 3 minus 2i minus 6 plus 4i plus 5. So I have to FOIL this out. So 9 minus 6i minus 6i plus 4i squared. Okay. And then from here, we just need to simplify powers of I. So this is going to be plus 4 times -1, which is -4. And then, like we've done in previous lessons, just combine all the real parts together. So 9, -4, -6, and 5. So that is going to give me 4. And then -6i, -6i, and 4i, and that gives me -8i. Well, I hope you have enjoyed this unit on imaginary numbers, and when you get to Algebra 2, we will do so much more work with them. I know you can't wait. Thanks for watching.